Alright, so today I'm going to be going over paper 1, which is a non-calculator paper, and this is for the June, although it was set in May, it's the June 2018 series of papers for GCSE maths, and this time we are going to be doing the higher tier. So let's get straight into question 1. So starting with question 1, we need to work out what the cube root of 64 multiplied by 1000 is. So what we can do is we can split this up into the cube root of 64 multiplied by the cube root of 1000, and this is a much easier situation that we can solve. So from here what we can do is we can solve the cube root of 64, which is equal to, this is equal to 4 multiplied by the cube root of 1000, which is 10. So 4 times 10 is of course just equal to 40, so the answer is the first one, so we circle 40. Okay, so for question 2 we are given the vector negative 2, 3, and this translates a to b, and we need to circle the vector that translates b to a. So if we just consider this, we've got the point a here, and to get to b what we do is we go 2 units this direction, so 2, and then we go up 3 units, and this gets us to the point b. So to get from b all the way to a, essentially what we're doing is the reverse of this, so we go down 3 and then we go to the right 2, so this is the vector of 2, negative 3, so all we've done basically is reverse the signs for negative 2 and for 3 to get 2 and negative 3, and we can see that this is the fourth answer, so the answer is 2, negative 3. Question 3, we need to circle the expression that is equivalent to 3a take away a multiplied by 4a and plus 2a. So this is essentially just a question of using BIDMAS. So the first thing that we need to do is this multiplication part here. So a multiplied by 4a is equal to 4a squared. Okay, so our expression now looks like this. We've got 3a take away 4a squared, and we've got plus 2a. So the next thing to do is simply add our 3a and our 2a. So this gets us 5a, let's put equals here and equals here. So we've got now 5a take away 4a squared, which is hopefully one of the answers, and it is, it's the third one here. So we circle the third one. Question 4, we need to circle the number that is closest to the value of 9.8 divided by 0.0195 out of these 4 options here. So what I'm going to do is I'm going to make this a bit easier for ourselves. So what we can do is we can multiply the bottom of the fraction by 100 as well as the top, and when we do this what we get is 980, and then this is all over 1.95. So essentially now what we're doing is we're dividing our 980 by roughly 2, as 1.95 is really close to 2. So when we do 980 divided by 2, in fact, you know, we'll round the 980 up to 1000 as well, that's pretty close to 1000. So 1000 divided by 2 is of course equal to 500. So the closest answer is going to be the third one, 500. Okay, so question 5, we need to solve 5 brackets x plus 3 is less than 60. So the first thing to do is of course expand our brackets. So when we expand this, what we get is 5x plus 15 is now is now less than 60. It's a terrible less than sign. Less than 60. Okay. Next thing to do is to take 15 away from both sides. So we are now left with 5x is less than 45. And dividing both sides by 5, we finally get x is less than 9. So the answer is x less than 9. Question 6 is worth 3 marks, and we are told the height of Zach is 1.86 metres, the height of Fred is 1.6 metres, and we need to write the height of Zach as a fraction of the height of Fred and give our answer in its simplest form. Okay, so the height of Zach we need to write as a fraction of the height of Fred. Okay, so we put the height of Zach, which is 1.86 metres, we put that on the top of our fraction. Then on the bottom we put the height of Fred, which is 1.6 metres. Okay, so the next thing to do is to simplify. So the first thing that I'm going to do is get rid of the decimal points. So we are going to multiply the top by 100 and the bottom by 100 as well. And when we do that, what we are left with is, I'm going to move this out of the way so we've got a bit more space. I'll put this here. Okay, so when we do that, we are left with 186 over 160. So we can then divide everything by 2. So we'll divide top by 2 and bottom by 2. And this will leave us with 93 over 80. And let's see, can that be simplified any further? We can't divide by 2 again, as 93 is odd. We can divide 93 by 3 to get 31, but we can't divide 80 by 3. So, yeah, this is the simplest form of the fraction. So the final answer is 93 over 80. Question 7 is worth 3 marks again, and we are told that we've got 3 coordinates, A, B and C, as well as D, so 4 coordinates, and they are on a straight line, A, B, C, D. We are then told, this is important information, that AB is equal to BC, which is equal to CD, and we need to work out the coordinates of D. So basically what this is saying here is that this length is the same as this length, which is the same as this length. So essentially we need to work out this distance here, and then we can work out the coordinate of C and then D. So what we've got is, from A to B we have gone up, so the change in the y coordinates is 3, so we can say that, let's draw a little triangle, we can say this length is 3, and the change in our x coordinates from 0 to 6, we can say this is 6. So to get to C, what we are then going to do is use a different colour, we're going to go up 3 units and across 6, so this is a 3 again, and this is a 6, which leaves the coordinates of C being 9, and then, not 9, sorry, so we've gone up 3 and across 6, okay, so we've got 12, and then we've got 8, okay, and then we do the same again, we go up 3 and across 6, that's a 6, that's a 3, so therefore the coordinates of D, we've gone across 6 again, so that's 18, then we've gone up 3, so it's 11, so the coordinate of D is 18, 11. Okay, so for question 8 we are told a coin is thrown 50 times and it lands on heads 31 times, and we need to write down the relative frequency that it lands on heads. So for relative frequency, I'll just call it RF. This is equal to the amount of times that a certain event occurs, so we'll put down heads, so this is equal to heads over total number of throws, that is. So therefore we can say our RF, relative frequency, is equal to heads, which is 31, over 50. We could leave the answer like this, but we can convert it to a decimal just so that's a bit nicer. So if we multiply everything by 2, top and bottom, we get 62 over 100, which is of course equal to 0.62. So the answer is 0.62. So for part B of question 8, we are told that Raj says the coin is biased towards heads, and we need to use the data to give a reason about why he might be correct. So we look at the data. For a regular fair coin, when it's thrown 50 times, we'd expect 25 heads and 25 tails, but we've got 31 heads. So therefore we can say, what we can say is, okay, there are 12 more heads than tails. And this is a reason as to why he might be correct. Okay, so for question 9, we are told that the range of a set of numbers is 15 and 1/4, and the smallest number is -2 and 7/8. And we need to work out what the largest number is. So as the range is 15 and 1/4, and we know what the smallest number is, essentially if we add our range, which is the difference between the smallest and the largest value, to our smallest value, we will get the value which is the largest number. So what we have to do is -2 and 7/8, and then plus 15 and 1/4. Okay, so we can rearrange this. So we get 15 and 1/4. Then we've got take away 2 and 7/8. Okay, the next thing to do is convert both of these mixed numbers into single fractions, or improper fractions as they're called. So the way we do this is, for the left hand side, we do 15 multiplied by 4 and then plus 1. So 15 multiplied by 4 is 60, and plus 1 we get 61/4. And this is take away 2 multiplied by 8 plus 7, so 23/8. The next thing to do is to get a common denominator, so we need to get the 4 and the 8 to be the same number. So we do this by multiplying our first fraction all by 2. So that is multiplying top and bottom by 2. So when we do that, what we get is 122 all over 8, take away 23/8, and then we simply subtract our numerators. So this leaves us with 99/8. It doesn't say to leave our answer as a mixed number, so we can just leave our answer like this. So the final answer is 99/8. For question 10, we are told that y is inversely proportional to x, and we need to complete the table. So we need to find the value of y here and the value of x up here. So the statement y is inversely proportional to x, this means that y is equal to, then we've got inversely proportional, so it's 1 over, then we've got x, but there's a factor in front of the x which is called k. So we need to work out what k is, and to do that we're going to use the two known values for x and y in the table that correspond to each other. So we can say that y, which is 4, is now equal to 1 over k multiplied by x, where x is 6, so we've got 6k. So therefore we've got 24k is equal to 1, so k is equal to 1 over 24. Let's just move this up a little bit, so we've got that here. Okay, so now we know what k is, so we can replace our k with 24 and simply sub in our values of x and y. So we can say that when x equals 12, we've then got y is equal to 1 over 12 multiplied by our k, which is 1 over 24. So y is equal to, we've got 24 over 12, so y is equal to 2. So that's one of the solutions, and our other solution is when, I'll use this colour, so when y is equal to 8 for this value here, so we've got 8 is equal to 1 over 24 multiplied by our x, so therefore 8 is equal to 24 over x, so x is equal to 3. Question 11, we are given a large rectangle that is made up of 3 identical small rectangles as shown. So we've got our 3 identical rectangles here to make our large rectangle. We are told the perimeter of one of the small rectangles is 15 centimeters, and we need to work out the perimeter of the large rectangle. Okay, so if we just take a look at our diagram, what we can see is we've got 2 lengths on the rectangle, of course. So we've got, we'll call this x, and then we've got a larger length for the other side of the rectangle here. So if we just look at the diagram, we can see that we've got 2 short sides here, x, and that is equal to the long side, so therefore this length here is 2x. Again, that's because these rectangles are all identical. We've got our short length here, which we've denoted as x, and we can see that 2 of the short lengths here make up the longer length, so therefore the longer length is 2 times the shorter length, hence 2x compared to x. Okay, so now let's see what other sides we've got in the triangle. We've got a 2x here, we've got an x, a 2x, and an x. So if we add all these up, we can say perimeter of rectangle, and then we can say it is equal to 2x plus x plus 2x plus x plus 2x and then plus x and plus x again. So let me just move all this over so that it fits onto the page. Okay, and let me just double check. So we've got 2x, x, 2x, x, 2x, and then our two final single x's here. Okay. So we are also told in this question that the perimeter of one of the small rectangles is 15 centimeters. So for the small rectangle, if we see what length we've got of course 2 of the 1x's and then we've got 2 of the 2x's here. So we can say that we've got x plus 2x plus 2x, and this is equal to 15. So therefore we've got 6x is equal to 15, and if we divide both sides by 3 we get that 2x is equal to 5, so therefore x is equal to 2.5. So if we go back to our small triangle, sorry, the large rectangle up here, what we can now say is that therefore large rectangle, which is equal to, if we just add all these up, what we get is 3x here, and then we've got 5x, 6, 7, 8, 9, 10x. So 10x, which is equal to 10 multiplied by 2.5. So therefore it's equal to 25 centimeters. I'll redo that 5, it's awful. 25 centimeters. Question 12, we need to put these numbers in order from smallest to largest. So we've got 3 numbers in standard form and then 1 number written as a decimal. So what we're going to do is we're going to change this into the standard form version. So 0.07 can be written as 7 times by 10, and then we see how many times we move the decimal point, once, twice, so times 10 to the minus 2. What we can then do is compare the values in the indices here to the minus 10, and we can see we've got 2 4s and we've got 2 2s. So the ones that have got to the power of negative 2 are going to be bigger numbers than the ones to the power of negative 4. So we need to consider these 2 numbers first because we are arranging from smallest to largest. So the smaller of these 2 numbers is the 6, because if we consider if we've got say 0.6, that is less than having 0.8, so therefore the 6 is the smallest. So we can label our smallest number as 6 times by 10 to the minus 4, followed by 8 times by 10 to the minus 4. We then move on to our minus 2 numbers here and here, and again we can see that the 7 is bigger than the 4, so the 7 is actually our largest number we've got here. So we then write our third smallest or second biggest is 4 times by 10 to the minus 2, and our largest number is 7 times by 10 to the minus 2. Question 13, we need to circle the volume that is the same as 15 centimeters cubed, and all the possible answers that we've got are in terms of millimeters. So essentially we need to know the conversion factor between centimeters cubed and millimeters cubed. So let's consider, let's say we've got a cube, which I'll draw really roughly. Okay, and let's say that this cube has got side length of 1 centimeter. Okay, so therefore the volume V is equal to 1 times 1 times 1, which is equal to 1 centimeter cubed. Now let's say we change, well we don't change, let's just convert into millimeters. So this would be 10 millimeters, as 1 centimeter is 10 millimeters. Then let's work out our volume. So we've got 10 times by 10 times by 10, and this is equal to 1000 millimeters cubed. So therefore from here we can see that the conversion rate is going from 1 to 1000, so we multiply by 1000 to get from centimeters cubed to millimeters cubed. So our answer is going to be 15 multiplied by 1000. So I'll just write something there really quick. and therefore we can see that our answer is going to be 15,000, so it's the first one. Okay, so question 14, for part A, we are told initially that patterns are made using straight lines and arcs. As we can see here, we've got pattern A, and then we've got pattern B here. And we are told that more rows are added to pattern B, so that the number of straight lines to the number of arcs is in the ratio of 10 to 9. And we need to know how many rows are added. So what we need to do first of all is we need to work out how many straight lines and how many arcs are added when each new row is added onto the pattern. So for pattern A, if we count the number of straight lines, we've got 1, 2, 3, 4, 5. So we'll say S is equal to 5. And then if we count the number of arcs, we've got 1, 2, 3, 4, 5, 6, 7, 8. So A is equal to 8. We'll then do the same for pattern B. So the number of straight lines, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So S is equal to 10. And then the number of arcs, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So arcs is equal to 12. So if we see the difference between these two sets of numbers, what we can say is for each row, or each new row, we get so we've got 5 new arcs as, not arcs, 5 new straights as 10 take away 5 is equal to 5. So we get 5 new straights, and we also get 12 take away 8, so we get 4 new arcs. Okay, so what we now need to do is we need to work out how many more arcs and straights do we need till we get a ratio of 10 to 9. So from here we can say S is equal to 10, so we'll just go here, we'll do S, and then we'll put a 10, and then we've got A for arcs is equal to 12, and we need to get it in the ratio of 10 to 9, okay? So the number of straights to the number of arcs, we need it to be in the ratio of 10 to 9. So currently it's in the ratio of 5 to 6, so we divide both of these by 2. So if we add on our 5 new straights and our 4 new arcs, what we get is we get 15 to 16. Okay, this is not in the ratio of 10 to 9, so we'll do another one. So we then get 20 to, if we add on another 4, we get 20 again. So this is now in the ratio of 1 to 1. So if we add on 5 again, we get 25 to 24. Again, this is not in the ratio of 10 to 9. So we do another one, 30, and this time we get 28. Okay, so we need to keep going until we get the ratio of 10 to 9. So I'm just going to move these up slightly. So we add on another 5, we get 35, this time to 32. We're still not there. We add on another 5, 40, and we get 36. And what we can see now is from this ratio we've got here, 40 to 36. If we divide both sides by 2 and then 2 again, so if we divide both sides by 4, what we are left with is we get 10 from 40 divided by 4, and then we get 9 from 36 divided by 4. So the actual question is how many rows are added. Okay, so we started with 12 and 10, which is our initial row here. So we've got 1 new row, 2, 3, 4, 5, and it's 6 new rows. So we can say that we need 6 new rows. That's quite a difficult question for 2 marks, but if you just follow this method, you know, it's fairly straightforward, but there's quite a lot of work to get the 2 marks there. So for question 14b, we are told we've now got a different pattern, and it's made using 20 straight lines and 16 arcs, and the straight lines and arcs are made from metal. Okay, so we've got 20 straight lines and they cost £12, and the ratio of cost for 1 straight line to 1 arc is 2 to 3, and we need to work out the total cost of the metal in the pattern. Right, okay, so we've got 20 straight lines in total and 16 arcs. Okay, 20 straight lines are costing £12 and the ratio is 2 to 3. So the first thing to do is we need to work out the cost of one straight line. So to work out the cost of one straight line, so I'll just say cost per straight, and this is equal to our £12 divided by the 20 straight lines we get for our £12, and this is equal to 0.6, so I'll just put in brackets 60p. Okay, so now what we need to do is work out the cost per arc, and we know that the ratio of S straight to arc in terms of cost is 2 to 3, so we can say therefore cost for an arc, so I'll just put cost per arc, and then what we've got is our 60p, and we're going to divide it by 2 to make this a 1. So if we divide by 2, so well, it should actually be 0.6, so I'll do 0.6 divided by 2, so this will get the ratio of 1 from here by dividing by 2, and then to get the ratio or the cost for one arc we multiply by our 3, so I'll then just put in brackets times by 3, and this is equal to 0.6 divided by 2 is 0.3, times by 3 is 0.9, so I'll just put in brackets again 90p, and I'll just move this over slightly. Okay, so now we've got the cost per arc and per straight, so the only thing left to do is multiply our two values for cost by the 20 straight lines and 16 arcs, so total cost, and then we've got 20 straight lines, and that is at a cost of 60p, so times 0.6, and then we add on our 16 arcs at a cost of 90p, and then when we add all this up, what we get is £26.40. So the final answer for the total cost of the metal in the pattern is £26.40p. Question 15, we are told that a biased dice is thrown, and here are the probabilities of each score. So we've got the probabilities for each score on the table here. We are then told the dice is thrown 200 times, and we need to work out the expected probability, or the expected number of times, sorry, that the score will be odd. So what we need to do is we need to work out the probability, so P of odd, and this is equal to, we've got our 0.25, 0.15 and 0.3, so we just add all these together to get the total probability of the dice rolling an odd number, so plus 0.15 and plus 0.3, and this is equal to 0.7. So what we then do is we do our 200 times, so 200 throws, and we expect 0.7 probability for odd, so we multiply our 0.7 by 200, and when we do this we get 140, so we expect to get 140 odd rolls. Question 16, we're told that the value of y is 20% more than the value of x, and we need to circle the ratio of x to y. So if we consider what 20% more is, it's 1.2 times that, so we can say that our initial ratio of x to y, where y is 20% more than x, so x we can just say is 1, and then y is therefore 1.2, as 1.2 times by 1 will give us 20% more. What we can then do is we can multiply by 10, so if we multiply both sides by 10, what we are left with is 10 to 12, and then we can divide by 2 to get the ratio of 5 to 6, so the answer is 5 to 6. Okay, so question 17 is all about the sine rule, and we're given this triangle here, and we need to circle the correct equation, and we've got 4 options. So, and all of them involve x, so what we need to do essentially is create an equation from this triangle in terms of x. So for the sine rule, what we can say is that the length of the side, which is x, divided by sine of the opposite angle, which in this case is 42, so divided by sine 42, is equal to any other side length, so we'll go for the one that's labelled 15, so is equal to 15, and then divided by the opposite angle for 15, which is the sine of 104, and hopefully this should be one of the equations, and it is, it's this one here, so we'll just circle that for our answer. Okay, so question 18 is worth 5 marks, and it's quite a difficult question. So we need to go through this quite slowly just to ensure that we don't miss anything out. So what we're given is a tunnel for a toy train, and the diagram shows the cross section of the tunnel in this diagram here, and we are given some more information, which is AD is a semicircle arc of radius 10, BC is a semicircle arc of radius 7, and the length of the tunnel, which is this length here, is 30 centimeters. So let's label that on 30 centimeters. And what we need to do is we need to work out the total area of all 6 faces of the tunnel, giving our answer in terms of pi. So if we label the actual faces we've got on the tunnel, we've got this face here, and if we think about it, on the back of the tunnel we've got another one of these, an identical face, so we've got 1 and 2. We've then got the roof or the outside of the tunnel, which is number 3. We've then got the inside of the tunnel, which is number 4. And the other 2 faces are the 2 rectangles, which are here and here on the underside of the tunnel, and they are 5 and 6. Okay, so let's work out the area of 5 and 6 first, as they are rectangles and probably the easiest to work out. So for 5 and 6, to work the area of the rectangle out, we know our width, which is 3, and our length, which is 30. So we simply do 3 times 30. But remember, we've got 2 of these, as we're calculating 5 and 6 here and here. So we need to multiply our answer by 2 as well. And this is equal to 3 times 30, which is 90, multiplied by 2 is 180, and our units are centimetres squared. Let's move on to our areas 1 and 2 now. So to work these out, essentially what we've got is a big semicircle, but I'll draw a circle here, take away a smaller circle, and then this will leave us with this area here, and then we just need to divide by 2 to work out the shaded area here. And remember, we've got 2 of these, 1 and 2, so we need to multiply our final answer by 2 at the end as well. So to work out the area of our big circle, what we do is we do our area, let me just say, right, 1 and 2 is equal to our big area, which has got a radius of 10, so 10 squared times by pi, and then we've got take away our smaller area, which is 7 squared times by pi. Okay, and we've got 2 of these, so we need to multiply our entire answer by 2. But then remember, at the same time, we've only got half of the circle, we've only got a semicircle, so we also need to divide our answer by 2. So in fact, what we can do is just cancel out the 2 2's. So when we work this out, we get 100 pi take away 49 pi, which is equal to 51 pi centimetres squared, and that is the area of 1 and 2 combined. So now let's move on to number 3. So area 3 is equal to, what we need to work out is our semicircle circumference, which should be obviously half of the full circle circumference, and we then need to multiply by 30 to get this area here. So for number 3, to work out the circumference, we need pi multiplied by the diameter, where the diameter is 2 lots of 10. So we do our diameter 2 times 10 multiplied by pi, and then multiplied by the length, which is 30. But then remember, we've only got half of the actual circle, so we need to divide our answer by 2 at the end. So really we could cancel out this 2 here, but I'll just put divided by 2 as well, just that the examiner can see where our logic is coming from. Okay, when we do this, what we get is 20 pi times by 30, which is 600, divided by 2 is 300 pi, and it's centimetres squared again. So the final length that we need to work out, not length, area, is number 4, and it's the same approach as number 3, but we've got a different radius this time. So for number 4, this is equal to 2 times our radius to find the diameter, where our radius is 7, multiplied by pi to find the circumference, and then we've got multiplied by our 30, which is the length, and then divided by 2 again, as we've only got half of the circle, so one semicircle, so half of the area. So this is equal to 14 pi multiplied by 30, which is 420 pi, divided by 2 is 210 pi centimetre squared. So our final answer, I'll use, I don't know what colour, I'll just use grey. So total area, and this is equal to 180 centimetres squared. We've then got plus 51 pi plus 300, which is 351 pi, plus 210, which is 561 pi, and it's centimetres squared again. So difficult question, but if we take it slowly we can get the right answer. Question 19, we're told type A batteries and type B batteries were tested, and the cumulative frequency diagram shows information about the battery life of type A. So this is our diagram here. We then need to estimate the interquartile range for type A. So if we look at the cumulative frequency column, we can see that there are in total 80 data entries. So if we divide 80 by 4, we are left with 20. So our first quartile is at the point 20. So if we go across from 20 and go down, we get 1100, and our upper quartile, if we take 20 away from 80, we get 60. So we go to 60 and go across and then down. That is terrible, let me redo that because you'll lose marks for that in the exam. You need to go down roughly on the same line and you get 1400. So therefore our interquartile range is the upper value 1400, take away the smaller value 1100, so this is equal to 300, and the units are hours, so 300 hours. Question 19b, we need to estimate the number of type A batteries that had a battery life of more than 1600 hours. So if we go to 1600 hours on our diagram, which is here, and if we do a straight line going up from 1600, we get to this point on our graph, and if we then go across from this point to find the frequency, we get roughly 76, but remember this doesn't mean 76 batteries, because it's all the data above this line. So really it's our 80 take away 76, which is equal to 4, so the answer is 4 batteries. Question 19c, we are given a box plot showing information about the battery life of type B, and the question is, on average, which type had the greater battery life, A or B? And using data from both diagrams, basically say why you're choosing that type of battery. So the key thing that we need to look at here is the median for both diagrams. The median here is 1300, and in our type A diagram, the median, which would be at the point 40 going across and then down, is at about 1280. So we can see that our median is higher in type B, so we can say type B, and the reason that we can give is type B has a higher median, and then just quote our data at 1300 compared to type A at 1280, was it? Yeah, at 1280, and that will be enough for the 2 marks, although I mean you can't say for certain as the median is not the average value, but it's as good as we can get in terms of estimating which has got the greater battery life. So type B, and it has a greater median. Question 20, we are told a linear sequence starts as shown, a plus 2b, a plus 6b, a plus 10b, and so on. We are then told that the second term has a value of 8 and the fifth term has a value of 44, and we need to work out the values of a and b. So if we just complete the sequence, what we can see is the A stays the same, but the B is increasing by 4 each time. So our fourth term would be A plus 14B, and then we get A plus 18B. So we are told that the second term has a value of 8, so we can therefore equate our second term, A plus 6B, is equal to 8, and we are also told that our fifth term has a value of 44, so our fifth term, which is A plus 18B, is equal to 44. What we can then do is make A the subject of equation number 1, so we can then say that A is equal to 8 minus 6B, and we can then sub our equation 1 into our equation 2. So I'll just write something on the side here. Sub equation 1, so I'll just put EQ1 into equation EQ2. And when we do that, we get 8 minus 6B is equal to, not equal to, sorry, we've missed out the plus 18B, then plus 18B is equal to 44. So we collect like terms, we get 8, and then we've got plus 12B is equal to 44, so therefore 12B is equal to 36, so B is equal to 3. And what we can then say, I'll just move all this over, is when B is equal to 3, A is equal to, and if we then use equation 1, we've got A equals 8 minus 3 times B, which is 3. It's not 3 times, it's 6 times B, so 6 times B, which is 3. So A is equal to 8 minus 18, so A is equal to minus 10. So then we just sub our answers in at the bottom. So A is equal to minus 10 and B is equal to 3. And just to check that we've actually got these answers right, we can go to term number 1. In fact, no, we'll go to term number 2, A plus 6B, and that should equal 8. So we've got A minus 10 plus 6 times 3, which is 18, does equal 8. And then term B, A plus 18B, so our A, so minus 10, plus 18B, which is 54, does in fact give us 44, so these are the correct answers. Question 21, we need to enlarge triangle ABC by a scale factor of minus 2 with a centre 4, 1. So the centre's already marked on our diagram down here, and the scale factor is minus 2. So when the scale factor is minus 2, essentially, however many points we move from our centre to get to A, we move double that amount in the opposite direction to get our new point. So we've moved, we've moved 1, 2, 3, 4 points to A, so therefore we're going to move 8 points in the opposite direction, so 2, 4, 6, 8. So this is our new point A. We're then going to do the same for our point B, so we've moved down 2 and across 2, so we're now going to move up 4 and across in the other direction 4, so 2 and 4, and this is our point B. And then for our point C, we've moved down 2 and then we've gone across 3, so now we're going to go up 4 and across 6, so up 4 and then we go across 6, so 2, 4 and 6. So this is now our point C. So if we connect our triangle together, we've got A to C, C to B, and finally we've got B to A. So that is our new triangle. Question 22, we need to say which of the following expressions out of these four represents the Venn diagram shown here. So let's go through them one by one. So the first one is A intersect complement of B. So what this means is we've got anything that's in A, and then it must also intersect anything that's not in B. So essentially what we get is this shaded area here. So this is A intersect complement of B. We've then got complement of b, which is anything that isn't b. So we'd have all of a apart from the bit that intersects b, as well as all the outside bit. We've then got a union complement b, so that is, we've got all of a first of all, and then anything that isn't b. So we've then got all this part. So we can see that that is actually our answer, but just to confirm the final one, complement of a union complement of b, so that means anything that isn't a or b, which is essentially the outside part. So the answer is the third one, a union complement b. Question 23, we're told that a shopkeeper compares the income from sales of a laptop in March and April, and we are given a table with data from April here. And the question is, by what fraction does the income from these sales decrease in April? So the information that we've got is the price is a fifth more than in March, and we've also got the number of laptops sold is a quarter less than in March as well. So to work out a fractional amount of the income from laptops for April, what we do is we take our 1/5 more than March. So if we've got, say, the initial price of the laptop in March was just one unit, and then it's increased by 1/5, so we add 1/5 to it. This is now equal to 6/5. Okay, so this is new price. And if our number of laptops sold is a quarter less, we do 1, take away our 1/4, which is equal to 3/4. And this is the new number sold. So then what we can do is we can multiply these two values together, our 6/5 multiplied by our 3/4, and when we do that we are left with 18/20, and if we cancel down, this is equal to 9/10. So when we take into account the price and number of laptops sold, we can see that we've got 9/10 of the value that we did in March. So this means that we can do our 1, the initial unit for price and number sold in March, and then we can take away our 9/10, and that is equal to 1/10, which is the decreased value in April, and we can convert this into a percentage, although actually no, it asks us for what fraction does the income decrease, so we can just say our answer is 1/10 basically. A bit of a difficult question, because you've got to think, how can we actually use fractions to work out a decrease in income, but the key information is 1/5 more, 1/4 less, and then we just multiply these two fractions together and we get 9/10, compare it to our original 1 for March, take away our 9/10, and we are left with a 1/10 difference, so the decrease is 1/10. Question 24, part A, we need to work out the value of 2 to the power 14 divided by 2 to the power 9 all squared, and we need to give our answer as a fraction in its simplest form. So the first thing to do is to work out this part of the expression here. So we've got 2 to the power 9 and then all raised to the power 2. So when we have a situation like this, we multiply the two powers. So we get 2 to the power of 9 times by 2, which is equal to 2 to the power of 18. Okay, and our new expression, when we take into account our 2 to the power of 14, is now this. We've got 2 to the power 14 divided by 2 to the power of 18. So when we have a situation like this, what we do is we subtract the powers. So we have 2 to the power of 14 take away 18, which is equal to 2 to the power of -4. And we know that 2 to the power of -4 is equal to 1 over, so whenever we've got a negative power, it's 1 over the base, which is 2 to the power without the negative sign. And this is equal to 1 all over 2 times 2 times 2 times 2, which when simplified, we get 2 times 2 is 4, times 2 is 8, times 2 again is 16, so the answer is 1 over 16, and that's the final answer for that question. Question 24, part B, we need to work out the value of 25 to the power of 3 over 2. So what we need to do here is we can rewrite this to make it just a bit easier for ourselves. So the base 25 stays the same, and then the 2 on the bottom of the fraction, this is the same as a square root sign, and then the 3 on the top of the fraction is the same as a cubed. So we cube the entire expression. Okay, so what we then do is we work out our square root. So the square root of 25 is equal to, we've got 5 and then all cubed, and 5 cubed is equal to 5 times 5 times 5, which is equal to 125. So the final answer for 2 marks is 125. Question 25, we are given the sketch of a graph y equals cos x from values of x from 0 degrees up to 360 degrees. And for part A, we are told cos x equals cos 60, and we need to work out the value of x when it is between 90 and 360 degrees. So an easy way to solve this question is to find cos 60 on our graph. So if we find 60 degrees, it's this point here. So if we do a line going up to where it meets our line on the graph, and then we go across. Okay, what we can then do is see that there's symmetry in the graph. So this is exactly the same as this point over here, so we can then draw a line going across from this point all the way across to where it hits the graph again, and we then draw a line down. I'll do that again because that's not exactly right. So a line going down, and we get, it should be exactly on this point here, it should be exactly on the line, but the point there is 300 degrees. So from the symmetry in the cos graph, we can see that the point cos 60 is the same as cos 300, so the answer is 300 degrees. Question 25 part B, we are told that cos x is now equal to the negative value of cos 60, and we need to work out the value of x when it is between 180 degrees and 360 degrees. So the first thing to do is mark on negative cos 60 on our graph. So if we go to our point cos 60, which is here, this point, what we can see is when x is equal to 60, if we go up from this red line and across, we get this point here. So the negative value of this, we go down the same amount and across, okay? Now to work out what value of x that this point occurs at, we can see that from the point cos 90, if we move across and up to there, we can do the same as the symmetry. We can move across 30 degrees and then down, and that is the point that we get to. So from this point, cos 60, we've moved 30 degrees to 90 and another 30 across, and then we go down to this point here, and we can see that this is the value of negative cos 60, and it occurs at 120 degrees. Okay, so I was going to actually say that this was the final answer, 120 degrees, but if we actually check the question, it says from values between 180 to 360 degrees. So what we need to have is a value between here, and again, the symmetry in the cos graph, we can see that this point that we've marked on here is exactly the same as this point here. So if we do another line going across, and then we go up, we get to the point 240 degrees. So as well as the answer being 120 degrees, within the range that we needed to say for this question, it's also 240 degrees. So the answer is 240 degrees. Question 26, we're told that B is 2/3 of C and 5A is equal to 4C. We need to work out the ratio of A to B to C, giving our answer in its simplest form, where A, B and C are integers. So the first thing to do is convert this piece of information into a ratio. So we're told that B is 2/3 of C. So B equals 2/3 of C. So the easiest way to turn this into a ratio is to get the B and the C onto one side of the equation. So we can therefore say that B divided by C is equal to 2/3. And what we can then do is convert this into a ratio where we've got B to C, B divided by C, in the ratio of 2 to 3. We'll then move on to the second piece of information, where 5A is equal to 4C. Again, the best way of doing this is to bring the 4 over by dividing by 4, and then bring the a over by dividing by a. So what we are left with is a over c is equal to 4 over 5. So again, the ratio of a to c, a divided by c, is in the form of 4 to 5. Okay, so in our two ratios now, we can see that we've got a b, a c, an a and a c, and we need to equate them all together somehow. So the best way to do this is by taking the value or the variable that occurs in both ratios, which is c, and getting the actual number that is related to c in each ratio to be the same. So the way that we can do this is we can multiply this ratio by 5 and multiply this ratio by 3, and when we do that, we get b to c is now equal to 10 to 15, and a to c is now equal to 12 to 15 as well. What we can then do is equate all three ratios together, so we can have a to b to c, and we can do this because c is now the same value in both ratios. So the value of a is 12, the value of b is 15, and the value of c is, b is not 15, b is 10 and c is 15. So these numbers can't be divided by a common factor, so this is the simplest form where a, b and c are integers. So our final answer is a is 12, b is 10 and c is 15. Question 27 part A, we're told that Joe wants to work out the solutions of x squared plus 3x minus 5 equal to 0, and she says the solutions cannot be worked out because that expression does not factorise into that form where a and b are integers. So we've got to say basically, is this statement correct that the solutions can't be worked out? Tick a box and give a reason. So obviously the solutions can be worked out, so Joe is wrong, and the reason is we can use other methods such as using the quadratic formula or completing the square. So I'll just put what can I put? The solutions can be worked out using the quadratic formula. And that'll be enough for the 1 mark. Question 28. Simplify root 80 plus 2 and 2/9 or square rooted. We don't like this, this is weird, we need to solve this obviously, and we need to give our answer in the form a root 5 over b, where a and b are integers. So like I said, we do not like this, don't like the look of it, so we need to solve it straight away. So what we're going to do first of all is turn our mixed number fraction into an improper fraction. So we can say our root 80 stays the same, and it's plus the square root of 2 times 9, which is 18, plus 2, so 20, all over the denominator, which is 9. So what we can then do is we can simplify this third, so we can change it into root 4 multiplied by root 20 plus root 20 over 9. Okay, so this is equal to 2 root 20 plus root 20 over 9. We can then simplify this further, so we can get 2 multiplied by root 4 again, multiplied by root 5, plus root 20 all over 9. So 2 times the square root of 4, which is 2, gives us 4 in total, multiplied by root 5, so we've got 4 root 5 plus the square root of 20 over 9. Okay, what we then can do is with this fraction here, I'll just draw an arrow up here because we're running out of room, we can almost split the fraction up into two parts, so we can have root 20 divided by root 9, and this is equal to root 20 over 3. We can then split our root 20 up, so we can say that we've got root 4 multiplied by root 5 all over 3, and this is equal to 2 root 5 over 3. So bringing it back to our original line of working, so down here, and we'll bring this down here as well, what we've now got is 4 root 5 plus 2/3 of root 5, and this is equal to 4 plus 2/3 will give us 14 over 3 root 5, and they want the answer in this form here, a root 5 over b, so we can easily just put it into that form. So this is equal to 14 root 5 all over 3. So the final answer is 14 root 5 all over 3. Question 29, we are given two graphs as shown in this diagram here. We've got graph A, and then we've got the graph y equals x squared minus 1. We are told the graph of x squared minus 1 is translated 3 units to the left to give graph A. So this graph is the same as graph A, it's just being moved 3 units to the left. Okay, so the equation of graph A can be written in the form y equals x squared plus bx plus c, and we need to work out the values of b and c. So if a graph is translated 3 units to the left, what this means is that the x value has had a plus 3 applied to it. And the way that I like to think about this is, say the point x equals 0 here, so it would be this point here on the graph. If we plus 3 to our x value, this means that the point that was it when x equals 0 is now going to occur when x is equal to minus 3. So this point here is therefore minus 3. So at the point minus 3, when we plus 3 to it, we now get 0, so we get the point that was at 0 before. So that's essentially how we know it's moved 3 units to the left. It's had a plus 3 applied to the x value. So we can rewrite our equation. We can now have y is equal to x plus 3, and this is all squared, and then take away 1. So y is equal to x squared, just expanding the brackets here, plus 6x plus 9, take away 1. So y is equal to x squared plus 6x, and then plus 8. So therefore, comparing this equation here to our equation, we can see that b is equal to 6 and c is equal to 8. So b is 6 and c is 8. Question 29 part B, we are told that the graph of y equals x squared minus 1 is reflected in the x-axis to give graph B, and we need to work out the equation of graph B. So the key pieces of information here are this equation and reflected in the x-axis. Okay. So if we look at the original graph, which is this one here, if it's being reflected in the x-axis, that means essentially this point is going to be up here somewhere, and this point is going to be way down here somewhere, and so on. So essentially we'll have a shape that looks something like this, and then going down on this side as well. So if we compare what's happened between this point, our new point here, and this point here, we can see that the negative value has become positive, and where this value would be is down here somewhere, the positive value has now become negative. So all we have to do is show that the equation y is equal to our original x squared minus 1. Essentially the negatives are now positive, as they'll be up here, and the positives are now negative, as they'll be down here. So the way we can express this in our equation is simply putting a negative sign, and then our original equation, which was x squared, take away 1, and then we can solve to get y equals negative x squared plus 1. So I'll put the plus 1 first, then we've got take away x squared. So that is the equation of the new line, y equals 1, take away x squared. Question 30, it's the last question on the paper and it's worth 3 marks. And it's one of those questions where if you don't know some of these things off by heart, you've got no chance of answering it basically. So we need to know cos 30, tan 60 and sin 30 off by heart. If we don't, it's essentially impossible to get any marks for this question. So the value of cos 30 is equal to root 3 over 2. The value of tan 60 is equal to root 3. And the value of sin 30 is equal to 1/2. So if we don't know these values, we're essentially stuffed for this question. We can't get the 3 marks. But if you do know these values off by heart, it's a really easy 3 marks to pick up at the end of the paper. So what we then need to do is apply the relative signs between the functions. So we've got root 3 over 2 multiplied by root 3, and then we've got plus 1/2. So root 3 over 2 multiplied by root 3 will simply give us 3 on top, as the 2 square roots cancel each other out. So we're simply left with 3 over 2, and then plus 1/2, which is equal to 4 over 2, which is equal to 2, which is, as they wanted us to show, an integer.